Welcome to video 3 of 3 for the plate tectonics videos. And in this last video, which is a narrated PowerPoint, I'm going to show you some actual examples of plate-related processes in Iceland. And the first thing to appreciate about the island of Iceland is that it's essentially the only place on Earth where a divergent plate boundary runs right through the middle of an oceanic island. So it's a great place to go to see real-world, boots-on-the-ground examples of geologic processes related to plate tectonics. So this is where Iceland is. It's out in the middle of the Atlantic Ocean, in between Greenland and Europe. And that red line slicing right through the middle of the island is the divergent plate boundary. So there's the mid-ocean ridge as a regional feature, and as I said, Iceland is one of the only places on Earth where we have the opportunity to study a mid-ocean ridge on the land above sea level. Iceland marks the boundary between the North American plate to the west and the Eurasian plate to the east. Interestingly, the plate boundary is a two-pronged plate boundary as it slices through Iceland. And the main place that we're going to focus on is this area, what's known as the Western Volcanic Zone. So here we are, and the main thing to appreciate about this diagram is that all the yellow areas are areas of plate boundary volcanism. These are areas called volcanic systems, and they consist of groups of fractures at the surface, and underneath those groups of fractures, we have molten rock that rises up to the surface and occasionally erupts out of the fractures to create volcanoes. And so we're seeing a beautiful example here of plate boundary volcanism related to the fact that the divergent plate boundary runs right through the middle of Iceland. And actually, it's the same thing with earthquakes. So if we were to add the plate boundary to this earthquake activity map, you can see that the plate boundary lines up pretty nicely with these kind of linear earthquake zones here and here and here, for instance. Actually, let me get rid of some of this, and I'll just point out in passing that right here and also here in Iceland, we actually have transform boundaries. That's really to be expected because, as we discussed in the previous video, divergent plate boundaries and transform plate boundaries often go together. That's what we call a ridge-ridge transform. And essentially what we're seeing up here in northern Iceland, I'll draw a simplistic diagram over to the right, is we have a divergent boundary that's known as the Kobinsi spreading ridge, and then to the southeast we have another divergent boundary. That's this area right here, and in between the two divergent boundaries right here we have a transform boundary. So that is to say that divergent boundaries and transform boundaries often go together, and we see that displayed really nicely in Iceland. So we're now going to go to Thingvellir National Park. This is in southwestern Iceland, as you can see on the location map, and it's probably the best place on Earth to see a mid-ocean ridge where it sticks up above sea level. So the next few photos are going to be from these three locations. This was a trip that I took a few summers ago, and we spent some time exploring this area. So here's a side view that is a geologic cross-section, and Thingvellir is in this kind of western branch of the divergent plate boundary that slices through Iceland. It's known as the West Volcanic Zone. And this is a photograph looking south. So as you might expect, you can probably guess by now what all of these mountains are on all sides of this plate boundary. They're volcanoes, and they're ultimately related to the fact that the Eurasian plate is diverging away from the North American plate in Thingvellir in Iceland. That's a person for scale. So you can see this this rift right in the middle of the mid-Atlantic ridge here is quite deep. And here we're just having a little bit of fun. We're kind of in the bottom of the rift, and you can think of this as actually the plate boundary. So there's the plate boundary, and one person is standing on the North American plate, and the other person is standing on the Eurasian plate. Keep in mind that plate boundaries, as I mentioned before, have a little bit of width to them. They're kind of wide and mushy, typically, some more than others, as we'll talk about. So it's not really possible to kind of straddle a plate boundary like these two people are doing, but still, we're in the general area of the plate boundary, and so it's sort of fun to pretend that we can straddle a plate boundary in this case. In fact, this valley right here is essentially one of numerous extensional cracks that collectively define the divergent boundary in this part of Iceland. And some more examples of extensional cracking related to plate divergence. There's a volcano in the background. Okay, just another location map of Iceland. And on this trip, we took every opportunity we could to stop wherever we saw the plate boundary or typical plate boundary features, typical extensional rifts, extensional cracks like you're seeing. And of course, we pretended in each place that we could kind of straddle the plate boundary. And anytime we crossed a plate boundary, we got out of the bus and set up these pictures. Well, not only earthquakes and volcanism, but we can begin to make sense of so-called geothermal features in Iceland. That is, features related to hot water bubbling up from the subsurface. And again, the reddish areas here and here represent this sort of bifurcated or branching plate boundary. So we're going to, in the next few slides, visit these areas. The Blue Lagoon, which is a famous hot spring in Iceland, the Strokur geyser, and also some mud pots and gas vents known as fumaroles. And notice that all three of these areas occur either on top of or right next to the divergent plate boundary in Iceland. So we have hot rock, indeed molten rock, magma, at a relatively shallow depth. And when snowmelt and rainwater sort of seep into those cracks that you saw related to plate divergence, as the water migrates into the subsurface, it comes into contact with very hot rock at a shallow depth, and it warms up to the boiling point. And the water then rises back up to the surface because being so warm, it's buoyant. And in some cases, the water just sort of slowly bubbles out of the surface again as a hot spring. And in other cases, like the Strokur geyser, the water actually erupts. You get a jet of hot water shooting into the air, which is a geyser. So here we are at the Blue Lagoon. This is one of the most famous places in Iceland. And again, the water is hot there. You can see it's quite comfortable. but the water is, maybe we should say warm rather than hot, precisely because the Blue Lagoon sits almost directly atop the divergent plate boundary that slices through Iceland. The reason the water is kind of bluish green in this case is it contains microscopic or even submicroscopic particles of silica. And those silica particles, it turns out, it just so happens that their optical properties are such that they reflect kind of greenish and bluish light. So that's why the water is sort of a bluish green or a greenish blue. Interestingly, this place, the Blue Lagoon, has a swim-up beverage stand right in the middle of the hot spring. So you literally just sort of paddle up in your swimsuit, and as part of the admission to the Blue Lagoon, you get a free drink, either a beer or this sort of slushy, icy beverage that my wife Naomi is drinking there. And interestingly, in Iceland, they refer to this stuff as crap. So we traveled halfway across the world to go to Iceland to have the privilege of drinking cold crap. There you go. Okay, here's an example of a geyser. So typically, at least this is actually true for many geysers, if not most geysers. This is the Strokur geyser in Iceland, and right before the geyser erupts, you get this hump of sort of glassy bluish green water. And less than a second after the hump forms, this happens. And you got to be quick if you want to get a picture of that, because by the time you see the hump forming, it's almost too late to get the picture. You have to kind of be ready to begin with. What's interesting about geysers is they're relatively rare. They only form in a few places on Earth, including New Zealand and Yellowstone and a few other places. But you need three conditions to form a geyser, which is just an erupting hot spring. You obviously need a lot of groundwater. You need a lot of water in the subsurface. You need a heat source, and you also have to have just the right type of plumbing system to bring that warm water up to the surface. That doesn't tend to happen everywhere, and so geysers are relatively rare features around the world. Not only geysers and hot springs, but Iceland is also known for its mud pots. And what happens here, it really is the same process. You have warm to hot water kind of migrating up to the surface, and along the way, if it's moving through muddy sediments, it can kind of loosen the mud and bring the mud up to the surface. And instead of a geyser or a hot spring, you get what's called a mud pot. And then a fumarole, on the other hand, is simply a volcanic gas vent. And right next to these mud pots, just maybe less than 100 meters away, there was a really interesting fumarole, and people were lined up 6 or 8 or 10 deep to have the privilege of walking through this fumarole with its noxious gases, including carbon dioxide and sulfur dioxide and hydrogen sulfide. This whole area smells like rotten eggs from the sulfurous gases that are seeping out of the ground in this location. What's also kind of interesting is that Iceland shares some similarities geologically with southeastern California along the San Andreas Fault. Here in Iceland, there's a divergent plate boundary. That's what allows geothermal heat to migrate close to the surface. And we actually see the same thing happening along the southern end of the San Andreas Fault, along the plate boundary between the Pacific plate to the west and the North American plate to the east. And in this area that I've circled, that's the southern part of the Salton Sea and also the Imperial Valley. There's actually a buried divergent plate boundary. And those blue and red and yellow squares are actually earthquakes that are occurring along the plate boundary. So we don't get geysers in southeastern California, but we certainly get mud pots and fumaroles, just like we do in Iceland. Again, both places are characterized by a strong component of plate divergence. Okay, so here's some bullet points to really make sure you are aware of, and that you can answer for the first quiz. So I'll let you look at those on your own.